So let's talk a little bit about command line processing. When I type a command onto this, there's actually several things which are occurring. One of them is we just seen alias rewriting. In other words, I type ls, but it actually got turned into so-called rewritten as, unpacked to, expanded to, whatever word you want to use. I prefer rewritten to this other thing, ls, minus l, because it was, so we can give it lots of aliases. And often those aliases are once again things that might be about bash or C. But there's several steps. That's just one of several steps. I kind of glossed over this last time. I totally glossed over this. I muttered about it, that there's more going on, like aliases, and we'll come to this. But there's several stages, and some of these have to do with things we haven't seen yet. One is, for example, the history here. So there's a rich history of using a special notation for history to reissue commands within Unix. And it can be used by people who use these systems a lot to really perform jobs very, very quickly. So for example, here I have my ls. If I want to repeat the last command, I can do exclamation point, exclamation point. I'll just repeat whatever command I last did. Maybe the command is rather complex. For example, maybe I go and I take a look at all files, and I want to grep for files that include foo. And there's two files. I can go and repeat that again. Maybe I go and I create, maybe in the meantime, I go create another file. I can say cat into foobaz or something like that and put some more stuff in that. And now, one thing I could do is I could go re-execute the most recent command that began with L. I put exclamation point L. Exclamation point repeats the most recent command. Maybe I went off into an editor or did something and I just want to repeat it, see what it gives, the most recent command in the shell. If I do exclamation point some character, it will repeat the most recent command I issued, which started with that character. In this case, I've done some work here. I created a file called foobaz, and then I said, hey, go reissue this command that's the most recent command that started with L. Where is that most recent command on this display here? Yeah, it's this ls. And that's actually this whole command wrapped into foo. So it's reissuing this whole command line, and hence it shows foobaz. Okay? This grep is basically looking for all lines coming out of ls that contain foo. Okay. We're going to see grep is much more powerful than that. This is just having to look for a string, which is an impoverished subset of its capabilities. We'll come back to later capabilities, but it is one we actually use a lot. Okay. Here we have the ability to use command information, and that's actually, history information on commands. That's the first thing which occurs, then rewriting aliases, and then tokenizing, dividing things up into tokens. There's the use of braces. You can indicate multiple files, for example, within your shell at a single time. So, for example, I could do ls things that start with foo, and that might be finished with foobaz. It won't work in this context, but it'll work in other contexts. And then tildes. So where do we see tildes before? You should have seen them some in your lab. So what's an example of a tilde? How if I go like this? What is that showing me? ls tilde. My home directory. How if I said this? Then I'd look at Grant Cheston's home directory, which I'm not going to do for privacy reasons, but I could look at his home directory if I were a system administrator, had a compelling reason to do it. Just to illustrate it without breaching privacy here, I could do ls ndo885, my particular name, and it will show me my folder again. And I can in fact look within there. I could look within my foo folder. It goes through several other things. Some things, for example, in the shell can expand arithmetic. For example, I could say echo, 2 plus 3, and, in this case, okay, why isn't that working? I would have expected that. Or I could do this for a command, pwd. So here's actually a command within this, which is echoing some information that's an output from another command. I could even do this. So here I'm echoing whatever ls returns, or ls minus a. I can echo that out using this command. There's ways to do arithmetic. Evidently, I'm using the wrong syntax here, or there's a contextual difference. And I can do path expansions. For example, I can have a wildcard here, and what is this going to give me? ls foo star. Yeah, all things that begin with the name foo, right? Or I could look for all things that begin with foo, and then have either, or followed either by a b, or followed by by an a, or something like that. And then subsequently by other characters, and it will limit it to these two things. Why did this one up here show me these 3 files? Because, ladies and gentlemen, foo is actually a folder, and it's showing foobar, foobaz, and then it's showing the contents of this folder called foo. Just as if I had typed ls foo, it will show me the contents of that. Because that's a folder that's caught up here, it's matched, it shows me all the contents of that too. If I want to just show things that, for example, have foo in additional characters, I could look at it in this sort of way. And we'll start to see some more uses of these expressions later. So it does path expansions, and then there's some sophisticated features associated with something called process expansions. For example, allowing me to take the output of one process. So suppose you have a command, for example, diff, that takes 2 files. You might have one set of things which run one command, one set of things which run another command, and it takes the outputs from these commands as the inputs to diff, in other words, compares them. That's what the job of this is, to kind of compare 2 things. So this compares two pieces of input. In this case, we could put diff foo and bar, where those are 2 files, but we could also have commands here that output, and then diff outputs the results of those commands. Okay. Now in TCSH, which is another shell which you can invoke, there's a smaller set of things which go on processing commands. Bash is a fairly extensive one. You have to realize that every time you type something into the shell, there's a fair bit that goes on to making sense of it, okay? And that's why if you type something like echo, for example, echo path, what is this going to show? This is again tying into the lab. Yeah, the path variable here, okay? It's actually expanding this. This is a variable that it's expanding, that's expanding as one of the stages within this this whole expansion. So there's a fair number of stages going into sort of it understanding what you mean and printing something out. Okay. Okay. So that was a little bit on command line processing.